outside, we also have to do the chain rule. So we have to do the derivative of the outside, leave the inside alone, the derivative of the inside. So this is the derivative of the out of the main function, 3, 2, leave the inside alone. And when I do the derivative of the in function, I have to do the derivative of the outside, leave the inside alone, times the derivative of the inside, right? So this is kind of a mess. So then if I clean this up a little bit, I have 3 times 2x, which would be 6x, and then sine squared x squared cosine x squared. So I think we're looking at answer choice E here. So don't be surprised to see them combine more than one rule in a problem. In this case, the chain rule twice. So, okay. So number 7. Before I tell you what to do this, let me make sure that I know what the right answer is. Okay. Number 7. This was their attempt to get us away from doing Bobo Botno eats DC. That's how most calculus teachers teach limits as you go to infinity, and so they put one on here that doesn't work on, to try to force you to really spot what's happening in the problem without the benefit of a calculator. So if you think about what's happening here, if I plug in a really large number, the top and the bottom are both going to be pretty big. But the difference is, because the top is a power function, it increases pretty rapidly, but not as rapidly as an exponential function, which is what we have on the bottom. The difference is in where the variable is. When the variable is the base, that's a power function. That kind of function increases pretty rapidly, but compared to an exponential function where the variable is in the exponent, not as rapidly as that. And as the bigger the x gets, the more noticeable the difference between the two values will be. So they're both going to get big, but the bottom is eventually going to get bigger much faster than the top. And in a fraction, when that happens, when the top is significantly smaller than the bottom, you're getting closer and closer to 0. So to kind of slap the hands of the AP Calculus teachers that teach Bobo Botno eats DC. So just keep in mind what this is saying. This is saying when x gets really large, what's going to happen to these. The top and bottom are both going to get really large, but the bigger x gets, the more exponentially large the bottom will be than the top. Another problem that I'm not really fond of, because not everybody teaches use substitution this way. I don't teach it this way, but so this says, using the use substitution, u equals sine x. Which of these would it be equivalent to? So they're telling you to make u be sine 2x. And so the derivative of that is, we have to do the chain rule. So we do the derivative of sine, leave the inside alone, times the derivative of the inside. So I'm going to have to give myself that 2 here and balance it with a 1/2 on the outside. So now I could do my u substitution. So it's going to become u to the 5th du. Right. The sine of 2x, that's u. So we're going to write that u to the 5th. And then the 2 cosine 2x dx is going to become u. Now when you change your variable from x to u on a definite integral, it also changes the bounds on your integral. You have to plug these numbers in for x to determine what the bounds would be once you've changed the variable, which is the part that I'm not crazy about. I don't teach them this way. What I would do is have you integrate this and then change back to x and use these two bounds. But that's not what they want you to do here, and I can hardly see that. Let's see. Pi over 2 and pi over 6. So you would need to plug pi over 2 and pi over 6 into your u and figure out what those were. So we're talking about the sine of pi and the sine of pi over 3 to get the bounds here. Right? So this is a crazy problem. It's got a lot of stuff in it. This is one of those if you want a 5 problems. So to figure these out, remember we have this trick, figuring out trig values for the first quadrant. So the sign of, oh, and that's maybe not, let's think about it. It's over here, not in the first one. All right, so this, on the unit circle, this would be the point -1, 0. So the sine of pi will, and then sine of pi over 3. Sine of pi would be square root of 3 over 2. So this is what your bounds would change to. Right. So which one is that? D? D. Right. I guarantee you that if we could see the breakdown percent of people got that right, it would be very low. That one, a lot of stuff in it. Okay, so let's see. Hopefully we get back to some easy stuff. All right, number 9. The function f has a first derivative given by, and they give you the first derivative. At what values of x does f have a relative maximum? So remember, you have a relative maximum anywhere that the first derivative is 0 or undefined, and I think about what a maximum is, right? It's a place in the graph where you reach a high point, where the derivative would either be 0 or in the case of a cusp or something it would be undefined. And the slope changes positive to negative at a maximum. So that's how I kind of remember that. So this derivative would equal 0. It's not ever going to be undefined because it's a polynomial. But it would equal 0 at 0, 3, and -1. Those are the 3 zeros. If you set the factors equal to 0 and solve, you're going to get 0, 3, and -1. So then we just test points to see at which of those does the derivative also change from positive to negative. So if I plug in -2, I'm going to get -2. This middle term is always going to be positive because of the square. So -2 times a positive times -1, so this would be positive. And then -1/2. Oh wait, yeah, no, that's right. Then if I plug in -1/2, I'm going to get negative, positive, positive. If I plug in 0, I'm going to get 0. So this is, oh, I'm sorry, I can't plug in 0. I'm in a hurry and I'm not thinking out loud. 1, I'm plugging in 1. 1, positive, positive. And then if I plug in 4, positive, positive, positive. Right. So it would be at -1. -1 only. That's the only place where it changed positive to negative. Okay, last one, and then we'll call it quits for today because obviously my brain is not in the right state of mind here. So let f be the function defined above for what value of b is f continuous at 2. So right now, f is not continuous at 2 if you just look at the first part, because plugging 2 in gives you 0 on the bottom. But if you factor the top, all right, the top and bottom have an x minus 2 in common, which means that there's a hole in this graph at 2. So basically they just want you to fill the hole with the second piece. So in other words, plugging 2 into the first piece, we want it to equal the same thing that the second piece equals. Doing some weird stuff here. Let's see. Is this an E? Like I said, this is another reason that I need to stop for today. Okay, so it is E. I just want to make sure. It's very often that you get that. All right, so we want the two pieces to be equal to each other when we plug 2 in for x. So here this gives me -3 equals b squared. It's not possible for you to square something and get a negative. So there is no such value of b. Lots of surprises in this little practice test for me. Okay, so out of the first 10, kind of gauge how you did. You go through, and there's the team test in here. You might go through and see if you see similar to these in those. So if you just flip back through, you should see the page numbers at the bottom start over again, and you should see 2013 and then 2012. Like I said, the answers are in the back. So this is the kind of thing that we'll do during the reviews. We'll do some multiple choice, and then we'll take a break and work some free response. The free response are really where we spend most of our time focusing because we haven't really done a lot of problems, but they do tend to do the same types of free response questions every year. So if you can learn how to do them, there's some easy points to be had in those questions. So anyway, hope to see you on Thursday.